Okay, welcome back. Today I'm going to be doing the fifth part of building an AI computer improviser in Max. What we're going to do today is make it so that we can save all this data, all these analyses, and save our onsets, and then load them back in. So we're going to save it all as, the slices will save as a .wav float32 file, and the others are all JSON files. And this will allow us to skip over the lengthy training if we're using larger audio corpuses. And then after that, we will add onset detection for the live input, because that is one thing I sort of forgot from the last video. So as you can see here, I have some audio already loaded in. This is a 10-minute solo guitar piece that I recorded myself. And just to sort of review what we have here, we have our MFCC analysis, chroma analysis, spectral grains, spectral descriptors, mel bands, and pitch, all here, and we have live matching for all of them. So if we do the chroma matching with my voice, see, it's working quite well. Great. So let's figure out how we're going to save this. So let's start with the onsets. Okay, so for the onsets, we will want to do a write to the buffer, and then we'll have to choose where to save the buffer. Whoops. But also, we'll need to make sure it's the right format. So, oops, I'm just going to copy this over from another patch, but it must be float32 in order to work. So we want it to be a float32. So we have our floating point numbers, 32 bits, and then we can just write our onsets. And so we can, let's just make a file on the desktop for this. So we'll call it test. Oops. We'll just stick with new folder. And so we'll call this, so again, we want it to be wave, and we'll call this onsets. And now if we want to load our onsets in, we just give it a read, and then we can locate that file here. And of course, we're just loading the exact same one, so it doesn't really make a difference. But we can also load it in by having read and then the file name or the file path there. Okay, so that's our onsets. And so now we're going to need to make some changes inside these objects in order to save all of this data and recall it. So I'll do it with the slices. Actually, I'll do it with the grains. So we basically just need a bunch of different write functions. So we'll just sort of go from top to bottom. So we'll need the standardization. So save standardization. We will need our two-dimensional data set here. Save 2D data set. We will need our full data set. Which is over here, I believe. Yeah, that's the one we want. We will need our grid data set. So it is a bit laborious But you can, when you do preload it, you can always do read and then the name of the JSON file, and it loads very quickly when you launch the patch. Okay, so we have save 2D dataset, save full dataset, save grid dataset. Now we need the two KD trees and the label set. Or in fact, yes, no, that's right. Okay. Save, let's do label set first. So that is this one here. And then let me just clean this up a little bit. And then our 2D KD tree, which will go here. And then save our full KD tree. That will go here. Great. So I believe that's all you will need. So we would go one by one and save them, and then we could load them upon launch if we so desire to have preloaded corpuses, which I will want to have eventually in this. So when you do ask it to save, it's important to add, so fluid, let's call it standard test.json. Yeah. So you have to add that JSON. It won't automatically populate that as a JSON file, but it will recognize it as such when it's saved with the .json suffix. Great. The only other change I made in here since the last video is that in our make note, oh no, that's not in this one. Oh yeah, we also want to, of course, if we want to be preloading things, we will need to have a way to speak to these objects. So we basically just want to have a whole bunch of receive objects for these 6 different objects, but then also for some of the details of the make note object. So we will have receive standard. We'll go to there, so we can just send it a read and then the name of the JSON file to load the standardization. For the sake of completion, we will also have a send for the UMAP or a receive for the UMAP. We'll need one for the 2D dataset. Here, it's going to get rather crowded in here. Our 2D tree, our full data set, and our, let me move that up here, and our full tree here, and our labels here. Great. Good. So that is all updated for loading in files. Now we will need a few more receive objects here, which will be receive name, and then it will be the gain. The speed, the window, and the panning. Or let's just do pan. So for this, we will have replace all three, or we'll replace even 4 with floats. Is that right? Start time, end time, yeah, 4 of them. Okay. So it will go in like this, 1, 2, 3, 4. And we will want to have a load. And do load bang, and we want to instantiate this with some standard settings, which will be 1 for the first 2. So that's a gain in the speed. For the window, we'll do 0.8, give it a slightly softer one. For the grains, I like the softer windows. For the onsets, slices, I like to have more trapezoidal, so a 0.9 window, or even 0.95. And then, of course, for pan, we'll just have it by default in the dead center there. Okay, so I will, off camera, go and make all these same changes to all the other ones, and also perhaps tidy up and encapsulate some of this so that it's a little bit more organized and presentable. But that is it for being able to save and load in pre-cooked corpus analyses. Okay, so now all we have left to do today is add our onset detection. So there are 4 different onset detection objects from Flucoma that I use. You could also make your own sort of cheap onset detection object using Delta, inside of Gen or however you do onset detection. For the sake of kind of continuity between everything, and because I think that they're sort of interesting objects, powerful objects, I'll use the Flucoma ones. So I've already looked at the buff onset slice, and I've added a few param objects here. One interesting thing to play around with is what metric. I find the 0th metric to be the most useful for my purposes, but there are others that can be useful, and maybe it could even be used in combination with each other. Okay, so let's go for let's start with the onset slice object. So we want fluid dot onset slice, and we're going to give it a few different, hold on one sec. No, that's not what I want. Okay, so we'll start with fluid onset slice, and we're going to give it some arguments here. So we're going to give it the 0th metric, as I said, and we're going to instantiate it with a threshold of 0.1. And now if I put my ADC into it, and we'll need the edge object coming out of it, because it gives a signal, it gives a pulse, da, 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 da. Yeah, good. So we could also min slice length is also an interesting thing. The FFT settings are also interesting to play around with. But for our purposes, you see it's already working quite well at that threshold. Shoot, I have this weird bug. There we go. We could also add the threshold here for being able to change it quickly. And let's send onset. There, like that. So now we'll have our attack. So if we have our receive onset, we already see how this could be useful, just doubling our voice. Da, 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 da. Ba, 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 ba. Anyways. Or maybe with these, oops, with these, da, 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 da. Not sure, oh, I think I made some changes in there and it's not sending. Okay. Oh, I know why. Anyway, I broke that one from when we were updating that, but that's all right. Okay, so there we have our fluid onset slice. Next we have fluid dot novelty slice. And for this, give it the kernel size. I found that for whatever reason, 3 works well for me. We should also have the threshold on hand. Where is that? There we go. And we can test this out similarly. So we'd send this as novelty. Ba. Da, 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 da. So if I just do da, 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 we could have it so that those are detected as onsets, but novelty, maybe it wouldn't trigger until I do something that is timbrally quite different. Ba, 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 ba. Yeah, so it reacts a bit differently, as you can see, the novelty slice. And similarly, we have fluid dot transient slice. For this, you want to give it the ramp up, ramp down, fast and slow ramp up, ramp down, onset threshold, offset threshold, apply a high pass frequency, give it a noise floor. This takes a lot of different arguments. So I'm just going to copy it in from sort of how I tested it before. And I find this one is often quite trigger happy compared to the others. Hold on. Running out of space here. I'm going to take these, bring them out of the way just for now. Da, 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 da. Great. So we could play around with that to get something more reliable. And then the last one is transient slice. And again, I'll just sort of copy that in from my other, from my testing before. And so this uses transients to do attack detection. See, this one is already a bit more, yeah. So each one pays attention to some certain different things. And I find that they all can sort of be useful in combination, even maybe using different onset slice metrics in combination. So these will be handy going forward. So I think that's going to be it for now. And I will tidy up this patch and then make it available. So let me just bring up what my plan is. So here, this is my GitHub. So the name that I'm giving this improviser is the tensed computer improviser. It is the coming after scuffed computer improviser, TSC. So that's wrong. Okay. So in any case, it'll be in here. Right now we just have the README, but I will clean this up and make a folder in here with the, I'll call it, tensed computer improviser part 5 or something like that. And I'll save it in a folder in here so that anyone who wishes to play around with it is able to do so. So with that, I think we're done for today. And I'm looking forward to getting into more sort of creative music making stuff. We have a lot set up now and a lot of possibilities. Okay, thanks for watching.